we're going to start with most common, the favorite of everyone, which is the violin. No, except for me, I prefer the viola myself. As you probably study in your part of the history of the instrument, it descends from the viol family. The only real existing member of the viol family is double bass because of the way that it's shaped. It curves down here. It's evolved as far as the upper strings are concerned, the violas and the violins and also the cellos into this sort of shape.
Talk about
it. It has several different parts. The scroll up here is purely decorative. It used to be a sign of workmanship when, for cellos especially, when you could carve one of these into the shape of a lion or something like that. It's just for show, really. And the fingerboard goes all the way down here. It's in black. It's a different kind of wood. It's a harder kind of wood that will withstand all the pressure that we keep putting with our fingers as we whack it on the string. The bridge and the tailpiece. This part of the instrument is the most sensitive and the most important part of the sound producing side of the instrument, rather than, let's say, the scroll, which is entirely decorative. The vibrations of the string, or all of the strings rather, transmit themselves through the bridge into the top of the top plate of the instrument, and then there's a little post inside, a little piece of wood called the sound post that connects it to the back of the instrument. In the end, both sides, the front and the back, vibrate, causing the air inside to produce that the sound vibration, which comes out through these sound holes up front. So a rather complicated process, but like all instruments, it's not really the strings or the wood which causes sound. It's the air. It's the vibration of air.
So this part inside is a resonating chamber.
Correct.
For the air.
Yes, and that's why we pay so much money to get a small piece of wood like this carved exactly right, or the sound post adjusted exactly right. In my stay here in South Bend, I've always at least once in the fall and once in the spring take an entire day trip to go to Chicago, where someone will take a little sort of metal device, take 5 minutes just to adjust the sound post, and it makes such a remarkable bit of difference. You spend hours on the train just to go there for 5 minutes of adjustment. It makes a huge difference.
Okay. Tell us a little bit about each of the strings and the kind of sound they produce, and what the knobs are for here, and
Sure. The strings are tuned in two different ways. These are for large changes of intonation. If your instrument's very out of tune, you would begin here. And these smaller little devices are called fine tuners, and therefore smaller adjustments. Your students today are probably too young to remember the days when radios had big knobs and small knobs as well. Everybody's on iPods these days, but I remember when I was a kid that when you tune to a particular channel, you had to use a large knob to get around the frequency and the small one to get rid of the static. So it's something like that. You'll notice that I don't use all of the fine tuners, and that's because when you don't have the fine tuner, the length of the string is actually extended, and it creates better sound. So most professional string players will use one or two, or use a special kind of tailpiece that doesn't sacrifice the string length in order to have these. But just for convenience sake, it's impossible to do without all of them. As it goes higher in pitch, it becomes more and more difficult to just tune with these at the top.
Okay. Would you show us now, play the different strings and show us how each of the different pitches that the strings are tuned to?
So this is a violin. We start with the A. The entire string family starts with the tune of A. Most of the orchestra, except for the brass instruments, tune of an A as well. So that's the second string. And above that is the E string. Below the A is the D, and then the G. So from top to bottom is E, A, D, and G.
Now, how does that compare with the next instrument?
The viola, which is the next instrument, actually shares the same three bottom strings, the A, the D, and the G, and we go down another fifth to, this is the viola, it's much bigger, you can see. Sure. So it's the violin and the viola. Hope it comes out clearly that there is quite a big difference in size. And the viola has an entirely different bow. Even though they look the same, a lot of the differences come to deal with proportion. That it's only a fifth lower. So instead of starting off with the high E string, we start off at the top with an A, D, G, and we don't have the E string, but we have a lower string, C. And the cellos would be one octave below it, so it would have exactly the same strings, but one octave below. The strings of previous instruments were made out of catgut, which has nothing to do with cats. I mean, people didn't go around hunting down, the next door neighbor's cats in order to make strings for the instruments. It's still pretty disgusting though, because it's actually the intestine linings of cows. So, and they used to take this, wind it up into a string, and they used to play on these for. You'd be surprised. This phenomenon was not something that only happened hundreds of years ago. In the early 1900s, people still mostly used catgut.
Now they're synthetic strings, is that correct?
Now we have various kinds of strings. Most of them are made out of some kind of metal. Some of them have some sort of synthetic material. We've come to a point where it's not just one material that goes across the entire string. We have two layers, the core and the winding. And with all sorts of expensive metals being used, gold, silver. The most expensive is tungsten.
Now, when you're getting ready to play on the viola or the violin, you have to prepare the bow to be able to
Correct.
play.
So it is an arrested position. You'll notice the hair is completely loose. And if we really want to make it totally loose, we can actually take out the little knob at the end, and you'll find that the bow opens up like this. And so the hair, that's the hair when it's completely loose. And then when you put it in here, it starts to tighten up already. And then when we are ready to play, we tighten the bow even further so that there is some tension across the strings. So, across the hair. And then when we press it down, the bow stick goes up and down.
Now, you also have to put rosin on the bow.
Correct.
Yeah.
Right.
What is rosin? Tell us what rosin is.
That's a good question. I don't know all the details, but I'm assuming that it is the same rosin as that of the sap that we get from trees. Without it, most of our hair, if you can tell, it's very smooth. It wouldn't create any sound. As we put the hair on the string and we want to create a good sound, we need some sort of friction. And the little bits of rosin touch the little hairs on the hairs of the horsehair, The horsehair is not just completely flat. If we view it microscopically, there's these little bristles that come out of the hair, which we can't see. It's not visible to the naked eye. But when we put rosin, that connects to it, clings to that, and it creates some sort of friction.
Creates friction on the string so that you can
Correct.
produce the sound.
You can tell some people who only learned a few months and they put too much rosin before a concert. When they start to play, you see this little cloud of dust that comes up from the instrument.